Thank you so much, both of you, for joining. So today, as already mentioned to you, we'll be starting with this chapter called distance, time, speed, and distance. Okay, so let's get started. Okay, so what is distance? Okay, what do we mean by distance? Okay, so whenever a body or an object travels from, let's say, from point A to B, okay, or maybe in some different fashion, something like this, or the body travels from one place to like this, okay, or something like this, okay, like this, okay, from starting A and finishes off at A, okay. The body actually covers distance, okay, covers a few of the distance over there, and that is what we actually mean by your, one second. So that is what we actually mean by your distance, right, guys? Okay, yep. And time is all about the amount of you know how do you say that, the amount of time only, right? Okay, so the amount of time period that has been elapsed to cover that particular distance is time. Okay, everyone knows it. And speed, the definition of speed is the rate at which the distance is being covered, okay, is being covered, okay. So that is why when we write speed, we write distance by speed, okay. What do we write? Distance by speed, okay, right now. So this is what we actually mean by distance, speed, and your time. No, 1 second. Yeah, let it be the top. Yes, now it's okay. So before I move further to the conversion unit, okay, I specifically wanted to talk about the relationship between distance, speed, and time, okay, so that it's easy for us to remember, okay. We studied this during our AFCA days as well. So this is your distance in this triangular fashion. In the upper part of the triangle, we have something called distance, and the downward part of the triangle at the left hand side we have speed, and to the right hand side we have time, okay. And these two things can be interchanged, right? And what we actually mean by this is that distance is a function of speed and time, and more specifically the operator that we'll be using in between is multiplication, right? So this is the only thing we need to know, and from here we can derive speed is equal to distance by time, and time is equal to distance by speed. So far so good, guys?
Yes, sir.
Okay, cool. So now let's understand something about the conversion units. Okay, so let us say we want to convert 60 kmph into meter per second, right? So 60 kmph into meter per second, 60 kilometer means how many meters? Okay, that means 60 kilometers into 1000, that many meters that has traveled. Okay, and meter per second it has been asked. We are converting into meter per second. Okay, and 60 kmph means kilometer per hour. Kilometer per hour. Okay, every single hour. So how many hours? How many hours? One. That means how many minutes? 60. But what we need to find in terms of seconds, and that is why, since each of the minute, 1 minute is equal to 60 seconds, that is why 60 minutes is how many? 60 into 60 seconds, right? So that is why we'll write another 60 over here, right? So 60 got cancelled. This one got cancelled, and that is 50 by 3, right? And there is a there is a straight formula for that when we want to convert kmph into meter per second. Okay, I have personally been confused many a times on that front, but still, if you remember it, that would be much better. Okay, so to convert kilometer per hour into meter per second, what we do, You see, if you do this 1000, that is the conversion from kilometer to meter, that is 1000, and 3600 the conversion of hour to second, which will essentially, when it when we simplify it, we'll get 5 by 18. So we multiply this by 5 by 18 to get that particular number. How much is that? 6, 3, 10. Okay, how much is that? 50 by 3, right? 50 by 3 is your answer. Over here we have got in these two spaces, right? So the conversion units from kmph to meter per second, what is that? What is that? 5 by 18. We multiply the given value by 5 by 18 to get the speed in terms of meter per second, right, guys? Okay. Similarly, let's understand, let us say there is some speed called, let's say called 75 meter per second. Okay. And you want to turn it into kmph. Okay. If you want to turn into kmph, okay, there's only two scenarios. The number one scenario is that it has to be multiplied. When we were talking about kmph to meter per second, we use the multiplication operator, right? Okay. Now from meter per second, just imagine if we do this multiplication, like let's say 1000 by let's not do that. Okay, that's so idiotic for us to do. So 75 meter per second. Okay, so in 1 second they have traveled how many? 75 meters. So in 1 minute how much they will travel? It will travel, the body will travel, that will travel into 60. And in one hour how much it will travel? It will travel this many meters. Okay, and now this meter has to be converted in the terms of kilometers, right? And that is why what we are doing, we are dividing it. What have always been telling you, whenever we use multiplication operator, it usually tends to increase the value, usually. Okay, not always. Okay, but for example, when it is in the negative number, so when you do the multiplication, it will decrease its value, right? So whenever we use this division operator, it tends to reduce the value of that particular number, right? Okay, so now when you solve this, if you solve this separately, this particular, you will find 18 by 5. Okay, over here, when we were doing over here, we found 5 by 18, while turning from kilometer kmph to meter per second, we multiply by 5 by 18, and we multiply by 18 by 5. That is the reciprocal of 5 by 18 when we are changing from meter per second to kmph, right? And this is what basically happens behind the scene. Okay, this gets cancelled. Okay, and this one goes 3 times, this one goes 4 times. Okay, what we are actually left with, 3 into 60 into 6 by 4, right? And how much is that? 15. That means 270 kmph. Okay, this is the speed, 270 kmph. Now let's just try to check 270 kmph. Let's just turn it into meter per second. How much do we get? How much do we get, guys? Okay, 9, 2, 30, 15. Did we get the same? 75. We started with 75 meter per second. Did we close the loop to get the 75 meter per second? Right? Okay. Is it clear? So far, so good, guys. Is it clear, guys? Yes or no? In just what I wanted to say, if you want to change from kmph to meter per second, what we do, we multiply by 5 by 18, and when we change from meter per second to kmph, what do? We multiply by 18 by 5. Is it clear to all of you? Is it clear to all of you? Yes or no? That's the whole point I'm trying to make. Am I audible, guys?
Audible.
Yeah. Is it clear?
Yes, sir.
Okay. Cool. Let's move. Okay. The next thing I wanted to talk about the average speed. Okay. Average speed, average speed is nothing but your total distance total distance covered by total time taken. Okay. Total distance covered by total time taken. Okay. What we essentially mean, we'll also learn about this average speed a little bit more detail when we go on to the next slide, the further slides. Okay, so this is what we actually mean by that. Okay, let's say somebody traveling at 50 kmph for 2 hours, and then somebody is traveling at the speed of 75 kmph for let's say for 4 hours. So what is his average speed? Okay, over here that person covered 100 km, and over here that person covered 300 km. Okay, so that means the total distance that person covered was 300 plus 100, that was 400, and the total time it was taken for him was 2 and 4, that was 6. Basically whatever you simplify, 200 by 3. Okay, 200 by 3 is your basic speed. Okay, kmph is your essentially the speed. Okay, one more thing you need to observe over here, that if the two speeds are given, the average speed of it will always okay, will always lie between these two numbers. Okay, lie between, right? We cannot have less than 50. Okay, we cannot have less than 50, and we cannot have more than 50 either. Both we cannot have, right guys, we cannot have both. Okay, it has to lie between 50 and 75 at all the cost, right? Now let's talk about little bit about the relative speed, right guys? So what do I mean by relative speed? Let us say a person A. Okay, let's say a person A and person B, both of them are running in the same direction. Okay, both of them are running in the same direction. Okay, let's say it's running at the speed of 10 kmph and the other person is running at the speed of 12 kmph. Okay, so basically what I mean to say over here is that, okay, the person A is chasing down person B at the speed of 2 kmph, right? Right, because 12 kmph, this is more than 10 kmph. Okay, so at certain point, eventually what will happen, that A will overtake B, A will overtake B, right? At some point of time, A will essentially overtake B right now. Okay, and let us say the distance between them is like, you know, 8 kilometers, just to say that. Okay, so how much time it will take? How much time it will take? Okay, for them, for A to chase down B. A is bridging the gap at the speed of 2 kmph. Okay, and 8 km, 8 km is the distance that needs to be covered, is the distance that needs to be covered at 2 kmph, right? Okay, so in 4 hours, in 4 hours, A will essentially cover up this distance of 8 kilometers. Right now, let us say two trains are running. Okay, one is running at the speed of 100 kmph, another is running at the speed of 200 kmph. Okay, so the train A and B, the train B is essentially leaving behind train A at the speed of 100 kmph right now, at the speed of 100 kmph, right? And what if these two trains were running in the different direction? One at the 100 kmph, the second at the 200 kmph. In that case, what would have happened? Okay, what exactly would have happened in that case? Okay, both of them would have been leaving behind each other at the speed of 100 plus 200, that is 300 kmph. Is it clear to all of you guys? Same is the case for boats as well, guys. Okay, right, same is the case for boats as well. Is it clear, guys? Okay, over there you will have upstream, downstream. okay, and the speed of boat. That these are the speed of boat. These are the only three things that you will be coming across while solving the boat type of question. Is it clear? Yes or no? Did you understand what is relative speed? Did you understand what is relative speed? So if you did not get this one, let me tell you, if by any chance you are like riding a bike, okay, you are riding a bike and you are there on the on the road, okay, you're there on the road and you are riding at the speed of 50 kmph, let's say, okay, and there is another person who is also riding at the speed of 50 kmph, right? Both of you, whenever you are when you are riding the bike, it will seem that both of you are stationary, right? Both you in relation to the other driver, the other motorbike driver, it will seem as if both of you are what? Completely stationary, right? Isn't it? Yes or no? The other case is that the other person is driving, let's say you are driving at a much higher speed, let's say at 80 kmph, the other person is driving only at the 50 kmph, you will overtake them, right? Let us say you are driving at a slower speed, let's say at 30 kmph, the other person is driving at the speed of 50 kmph, you will be left behind. Did you guys get it? Yes or no?
Yes, sir.
Cool. Shall we move now? So we'll move to the next slide. Yeah. So there are a few of the rules. I'm not a very big fan of all these rules. Okay. So the rule says that if A travels with a speed of x kmph for t1 hours and with a speed y kilometer per hour for t2 hour, then average speed is equal to x t1 plus y t2 divided by t1 plus t2, right? It's very much intuitive. It's very much intuitive right now. Okay. They have given the example over here. A man travels at the speed of 5 kmph for 6 hours. Okay. And 4 kmph for 12 hours. Then what is the average speed? Then what is the average speed? Average speed is equal to total distance by total time. Total distance by total time. This is what we have studied. Okay. So in the first case, what is the distance that they have covered? At 5 kmph for 6 hours. This will be the distance, right? Because distance is equal to speed into time. Every one of us knows it, right? Every one of us know it, right?
Yes,
And in
sir.
the second case, 4 into 12 divided by how much of total time they have taken. Okay. 12 plus 6, that is 18. That means 30 and 48. That means 78 divided by 18, which means 9 and 39 and 13 by 3. Okay. That means what? Did I do the calculations right, guys?
Yes, sir. I think none of this.
Yes. So 4 and 1 by 3, D, none of these will be your, none of these will be your answer, D. Okay. It's pretty much intuitive and there is no formula for us to learn. The truth is this. Right? Shall we move, guys? Yes. When I was teaching you guys harmonic mean, okay, we came across this concept basically, okay. And over here we have something like this. If a man or a vehicle covers two equal distances with a speed of x kmph and y kmph respectively, okay, with the speed of x kmph and y kmph respectively, then the average speed of the man and vehicle for complete journey will be 2xy divided by x plus y. Okay, right. So let's say what it says in the example and formula. If a man covers half of his journey at 6 kmph, half of his journey at 6 kmph, and the remaining half at 3 kmph, then what is the average speed? Okay. Let's say if entire distance was d, so this must have been d by 2 and this must have been d by 2. That means the same distance have been covered, right? So if this is the case, what we do, we find the harmonic mean of the given speed. And what is the harmonic mean of the given speed? 2ab by a plus b. Okay, that means how much is that? 36 by 9, that means 4 kmph. Right. Let's just try to understand in a little bit of a different way. Okay, let's just try to understand d. Okay, so let's say d is equal to, let's say, 12. Okay, let's say d is equal to 12. What would have happened? Okay, this d by 2 would have been 6, right? Okay, average speed, what did we understand is equal to what? Total distance, by total time. Let me write it tt. Okay, so what is the total distance? What is the total distance, guys? Okay, so the distance is 6 plus 6, that is 12, and it is being covered. See, it is being covered. T1 will be how much at the first half? Distance by time, distance by speed. Okay, distance by speed, that means 1. Okay, and T2, what will happen? Distance by speed, that means 2. Okay, so that means 1 plus 2, that means 12 by 3, that means 4 kmph. Right, guys? Is it clear? Irrespective of the fact, no matter how much distance they are traveling, whether they are traveling 12 kilometers, whether they are traveling 36 kilometers, whether they are traveling 1200 kilometers, whether they are traveling 12,000 kilometers, whether they are traveling 1000 kilometers, their average speed will remain the same, which will be 4 kmph. The only condition is that it should have been, the distance should have been constant. Okay, if it is a full length journey, the two parts of it, the distance should have been pretty much the same. And if it is like, from A to B, he has one leg of journey, and from B to C there is another leg of journey. Okay, and in that case both of it will remain the same. Okay, basically the distance is constant. Right, guys? Right. Shall we move? 2ab by a plus b. When distance is constant, average speed is equal to 2ab by a plus b. Remember that. Okay. Okay. Yes or no? Yes or no, guys? Shall we move? Shall we move, guys? Are you guys there? Shall we move?
Yes, sir.
Yes. Thank you. I can't let you sleep. So sorry. Yes. This one. Look, I'm not a very big fan of formulas per se. But if you want to learn formula, I came across this formula in the book. So it was like pretty much imperative for me to tell you about these formulas. So let's learn. Okay. So if a man changes his speed to x by y of his usual speed, okay, and get late by t minutes, then the usual time taken by him is t into x divided by y minus x. Okay, this is what they have given. And there is another note over here. And if a person changes his speed to x by y of his usual and reaches early by t minute, then the usual time taken by him is t x divided by x minus y. Right, guys? Right? Okay. So let's just try to first understand using the formula. If a man travels at the speed of 2 by 5, 2 by 5 times of his original speed. His original speed was something. Okay, we don't know. Let's say something called x. Okay, original speed was something called x. And now it has become 2x by 5. Okay, and he reaches the office 15 minutes late. Right? To fix time, then what is the time taken with his original speed? So if we use the formula, how much time he has got late? 15 in minutes into x is how much? 2. Okay, and y minus x is 3. That means 10 minutes is your answer. Clear? Clear, guys? Now let's
Yes,
just
sir.
try to understand using a different way as well. Okay, we all know distance is equal to speed into time. So D is equal to ST, right? Distance is all the more common when the speed was S. He used to reach at the speed of he used to reach in the time T, right? But when his speed got 2 by 5 times of it, he became he became late by 15 minutes. That means T plus 15 by 60. Why I'm writing it by 60? Because I'm turning it into what? Hour. Okay, right. I'm turning it into hour right now. Now let's just try to solve it. How it happens? D is equal to 2s by 15 into T plus 1 by 4. Okay. Now these two D's are equal, which means what? ST is equal to 2s by 5 into T plus 1 by 4. This S got cancelled. Okay. 5T is equal to 2T plus half. That means 3T is equal to half. That means T is equal to 1 by 6. Okay. 1 by 6 hours, right? We have changed over here by dividing by 60. We change this value to hour, right? Okay. So 1 by 6 hour is equal to 1 by 6 into 60, which means what? 10 minutes. 10 minutes. Right, guys? So if you do not know the formula, you must be able to put it in these terms. Okay, you must be able to think in these terms. Okay, first is distance is equal to speed into time, and then what happened that your speed it became 2s by 5 times, and then t plus 15 by 60. Right, guys? Is it clear? Is it clear to all of you? Yes or no?
Yes, sir.
Cool. Still in the event? Yes. So when a man travels from A to B with a speed of x kmph and reaches t hours late, t1 hours late, after that, that person fixed the time when he travels with a speed of y kmph from A to B. He reaches his destination t at t2 hours before the fixed time. Then the distance is given by xy into t1 plus t2 divided by y minus x, right. Let's just try to put in the formula what happens. Okay, so x and y are basically your x and y. X is equal to 3, y is equal to 4. Okay, while traveling at x is equal to 3, Rajiv reaches 5 minutes late. Okay, and with this he reaches 5 minutes early, right? 5 minutes late and 5 minutes early. Okay, and we are not bothered about all these early and late or anything like that, because we are using the formula. So xy, that means 3 into 4, t1 plus t2, 5 minutes early, 5 minutes late, that means 10. Okay, 5 minutes, this is in the terms of hours. Okay, so let's just 10 by 60, right, in terms of hours, to y minus x. Y minus x, the value itself is 1. This got cancelled. Okay, by 2 times, 20 times, this got cancelled. 2 kilometer is your distance over here. Okay, but you should know why and how exactly it's happening, right, guys? Why and how exactly it's happening? Because a slight twist here and there, the formula will go on to a toss, right, boys? The formula goes on to a toss with slight twist here and there. Okay, so the drill remains the same. The drill remains the same. Okay, and I'll let you know how. Distance is equal to speed into time. T is equal to S2. Okay, first scenario, distance remains the same, right? And also in the second scenario, the distance will remain the same, right? Walking at 3 kmph, that means speed is 3 kmph. Rajiv reaches his school 5 minutes late. Okay, that means sometime we do not know that particular time, plus 5 by 60. We are doing it in terms of hours. That is why and again d is equal to speed, that is the another scenario, into t 5 minutes. Now this time he reaches 5 minutes early, that means t minus 60. Now this t, these two, can we equate these two to find the value of t, guys? Can we find the value of t from here? Yes or no? Okay, so that means 3t plus 15 by 60 is equal to 4t minus 20 by 60, right? This is your 4t, okay, which is equal to 35 by 60 is equal to t, right? Now 35 by 60 is equal to t, right? T is in hours. Now let's place this t over here in any one of these two equations. So d is equal to 3 into 35 plus 5, that is 40 by 60, right? That means 2 by 3, this 3 got cancelled. What do we have? 2 kilometers, same. Is it clear, guys? Is it clear? Guys, is it clear? Yes or no? Is it clear? No. Is it not clear? If, let's say, if the person was reaching at t time, okay, let's say he was supposed to reach at this particular time, when he was walking at the speed of 3 km/h, obviously he will reach late. He reached late by 5 minutes, right? But when he was walking fast at the speed of 4 km/h, he reached at this space, that means 5 minutes early, right, guys? 5 minutes early. Is it clear? Yes or no? Yes or no, guys? Yes or no, guys?
Yes, sir. Fine.
Sleeping?
No, sir.
Yeah, don't. Need to stay strong till 12. Yes, this one. A person travels from A to B with a speed x km/h and reaches t1. Did we do this one? Okay. Yeah. A person travels from A to B with a speed x km/h and reaches t1 and reaches at t1 hours late. Okay. Later he increases his speed by y km/h to cover the same distance and he still gets late by t2 hours. Okay. Then the distance between A and B is given by this formula called t1 minus t2 into x plus y into x by y. Okay. So what is t1 over here, guys? T1 is 30 minutes. That means 30 by 60 hours. T2 is 10 minutes. That means 10 by 60 hours. Right? And what is x and y? X is your 20 kmph and y is what? Increasing his speed by 5 kilometers. Okay, so y is equal to 5 kmph, right? So t1 minus t2, that means 30 by 60 minus 10 by 60 into x plus y, that means 20 plus 5 into x by y, that means 20 by 5. Can you guys calculate and tell me what is the answer? 3 times gone? 100 by 3? 100 by 3. Yeah, that's it. Is your distance is equal to 100 by 3, right? This
Yes,
is
sir.
what the usage of formula is. Now let's try to understand what exactly happens. Okay, same formula. Let's say distance is equal to speed into time. Yeah, that's it. In the whole chapter of time, speed and distance, if you know distance is equal to speed by time, and if you have practiced enough, you can solve any bloody ruthless question, right? So the case 1, he basically has to reach from point A to point B. So distance will remain the same always, right? So in the first case, he travels at the speed of 20 kmph and he reaches late. That means the time at which he was supposed to reach plus 30 minutes. Changing it into what? Changing it into hours. And in the second case, he increased his speed by 5 kmph. Okay, So now at what speed he traveled? He traveled at the speed of 25 kmph, right guys? Okay. But still he is late by 10 minutes. Still he is late by 10 minutes. If he is late, that means the time taken over here will be more than the t. That is why we have this plus sign in between. Is it clear? Now let's just try to solve this equation. How much do we find? T plus 10 by 60, that means 20t plus 600 by 60, 25t plus 250 by 60. I have purposefully not simplified this over here. You know why? Because ease of calculation. Okay. This will go this side, so we will be left with 5t, right? And now this will come this side, we will be left with 350 by 60, right? So this one got cancelled, this one got cancelled. That means t is equal to 7 by 6 hours. Okay. 7 by 6 hours means also mean by 70 by 60. Why we have written 70 by 60? Because our calculation we need to be easy. Now pick up one of these equations over here. D is equal to 20 into t. T, the value of t we have found out, that means 70 plus 30 divided by 60. Okay, which means nothing but this will go 3 times. That means it will give you 100 by 3 kilometers. Is it clear, boys? Is it clear? I mean, is that tough? I think remembering the formulas are tough. Right? No? Who will remember all these formulas? I don't. Shall we move, guys? Yes. Time taken by a train X meter long in passing a single post or pole or a standing man is equal to time taken by train to cover X meter. Easy. What it essentially means by saying that is that if there is a pole, if there's a pole and if there's a train, let's say there's a train, what it is saying is that the time taken by, and this is let's say the length of the train, okay, the time taken by the train to pass this particular pole P is same as the time taken by the train to cover the length of the train, right now, to cover the length of the train, right? Hmm? Is it clear? Is it clear, guys? Obviously, if there's a pole over here and if it's a, let's say, train over here, okay, so obviously the train will have to reach at this particular place in order to complete this one, in order to completely cover this one, right? In order to completely pass this one, the train will have to reach over here. The back side of the train will have to reach over here. That means it started from here and the back side of the train right now is here. Okay. Is it clear? Yes or no? Yes or no, guys? Yes or no? So if the back side of the train is here, that means it will have to have traveled this length of the train L. Right, guys? Okay. So this is what is being told in your rule number 6, first point. Okay. Then is the time taken by a train X meter long in passing an object of length Y. Object of length Y. Okay. Let us say there's a platform. Platform P 100 meters. Right. And there's a train over here. A train doesn't really look like this. It will come, it will start, and at this point, the train will come over here, right? At this point, it will start passing this platform, and by the time the rear of the train reaches at this particular time, at this particular place, we'll conclude that yes, the train has passed. Right, guys? Yes, the train has passed. Yes or no? So this is what they are telling, that the time taken by a train X meter long in passing an object of length Y, okay, of length P is equal to time taken by a train to cover X plus Y meter. Okay, that means over here, let's say the length of train is L. That means the time taken by the train to cover L plus P will be same as the time taken by the train to, leave the platform. Is it clear, guys? Let's do the example number 9 and tell me what is the answer. What's the answer, guys? What's the answer, guys? 100-meter long train And if it's a signal post, it will be like this. The distance of this signal post is negligible, so we do not count that. Basically, that's how happens. So the train is running at the speed of 60 km/h. Okay, we need to turn it into meter per second 5 by 18. Right? How much is that? 320. 100 by 3. Right? No, 100 by 3. Is it correct?
Yes.
So this is your what? Speed. Speed in what unit? Meter per second. Okay. So time is equal to distance. How much distance they need to cover? The pole needs to cover 100 meters only. Time is equal to distance by speed. So how much time it will take? 3 seconds it will take, right? We have already turned it into meter per second, right guys? Is it clear? Boys, is it clear?
Yes.
Shall we move?
Yes.
Yeah. Okay. So time taken by a train of length L1 meter moving at the speed of S1 to cross another train of length L2 moving at the speed of S2 in the same or opposite direction is L1 plus or minus S1 plus or minus S2. Right. I'm not a very big fan of all these formulas, but let's just try and find out what they essentially mean by saying this. Two trains of length 100 meters, and let's say this is the train, these are the two trains, are on the parallel track. Okay, these are on the parallel track. Okay, let's say it looks like this, isn't it? Isn't it? Okay, this one is 110 meters, this one is 130 meters. If they move in the same direction, they're all moving in the same direction, this direction. Okay. The first one, which is faster, takes 1 minute to pass the another one completely. Okay. The faster one, let's say any one of these is the faster one, and it takes 1 minute to pass the other one completely if they move in opposite direction. If they move in the opposite direction, then they pass each other in 3 seconds. Okay. Then the speed of the train is. Time taken by a train of length L1 meter moving at the speed of S1 meter per second. Okay, they have given the options. Okay, in both the cases, whether they are moving in the same direction or the opposite direction, one thing is pretty much clear that 110 will have to be added by 130. Okay, which means what will we get? 240. When in opposite direction, it passes each other in 3 seconds. In 3 seconds means what? In 3 seconds, that means in 3 seconds, their distance between them when opposite direction, the gap between them of 240 meter is closed. And to close this gap, every single second, 80 meter of gap needs to be closed. Where do you find the sum is equal to 80? In option A and option B and option C. Okay. Option A is 41 meter per second, 39 meter per second. Add these two, we get 80 meter per second. Okay. And the case of C is also pretty much the same, which is 80 meter per second. Now, if they move in the same direction, this was the opposite direction case. Okay. If they move in the same direction, the faster one takes 1 minute. 1 minute. 1 minute means what? 60 seconds. That means 250 meters of gap is closed in 60 seconds. That means each of the seconds, 4 meters of gap are being closed, right? So where do we find the difference of speed at S4? Where do we find the difference of speed? Why difference of speed? Because they are in the same direction. One is at 42, another one is at 48 meter per second. That means the one who is running at the higher speed will essentially overtake the other one. Okay. And what will be the relative speed 4 meter per second, and this is what your required value is over here. Is it clear, guys? Do we have to understand the formula as such? There is no formula anything as such. It's all about the logic. Is it clear? Is it clear, guys? Try to soak in with my mindset. Do not look for any chain of thought, any flow of thought. Right? I know somewhere I started with all these, options and all, but we have to start with the options because they haven't given us any, you know, speed S1 and S2 over here as given in your rule number 7, guys. Right? Is it clear? Shall we move? Yes. If two trains start at the same time from point A and B towards each other, okay, from point A and B towards each other, and after crossing each other, they take T1 and T2 time reaching point B and A respectively. A takes T1 times and B takes T2 times to reach this place, okay, respectively. Then the ratio of the speed, ratio of their speed, which they have not given, is equal to, see, why? Because the distance is constant, right? Okay. Why do we write speed is equal to distance by time, okay, or otherwise distance is equal to speed into time, okay, right? So if the speed is more, speed is equal to, then their ratio of speed d by t is equal to s, okay. What we see, the s and t, both of them are inversely proportional, okay, inversely proportional. That means what? If the speed increases, time will decrease. If the speed decreases, time will increase. This is what we mean by inversely proportional. What is the relationship between d and s? It is directly proportional. If s increases, d increases. If s decreases, d also decreases, right? And this is what we mean by over here, the relative speed or the ratio of the speed is equal to root under T2 and not T1, okay, by T1 is equal to S1 or S2, right? Two trains, one from Howrah to Patna and another one from Patna to Howrah, start simultaneously. After they meet, the train reaches their destination at 9 hours and 16 hours respectively, okay. This is your Howrah, this is your Patna, okay. It takes 9 hours, it takes 16 hours, okay. So that means the ratio of speed T2 means 16 by 9. What is the ratio of their speeds? Is 4:3. Is it clear, guys? Is it clear to you guys?
Yes, sir.
Yeah. And let's just try and understand what exactly happens. Let's just try and understand with the normal thing. Okay. This is your Howrah. This is your Patna. Train A, it reaches in 9 hours. And this one reaches in 16 hours. Okay. Right. Let us say the distance between them is 144 kilometers. That's just an assumption. Okay. That's just an assumption, guys. Okay. We can take any number of values, but let's just, for the sake of simplicity, we have just found out, we have just simply multiplied 16 and 9 to get this number, okay, 144 kilometers. So what is the speed? Speed of A, let's say this one, the one going to Patna, speed is equal to distance by time. How much is that? 16. Speed 1, let's call it speed 1. Then speed 2 is how much? 144 by 16 is equal to 9. Now, what is the ratio of speed 1 is to speed 2? 16 kmph and 9 kmph. Right, guys? One moment. Yes, guys. Speed 9 kmph and the ratio of the speed is 16:9. S1 by S2 speed is equal to, yes, okay. So what did we observe over here? That S1 by S2 over here, that means this one is your S1 and this one is your S2, is basically nothing but 16 by 9, which is basically your root under T2. Time taken by 2 is how much? 16 hours, right? By time taken by 1 is how much? 9 hours, right? So if we do 16 by 9 is your 4 by 3, right? No, 4 by 3. What are we doing some calculation error somewhere or what? One moment, guys. Speed
4
is
is to 3.
yeah, 4 is to 3. Yeah, absolutely. Yeah, that's correct. Okay, but then these two are not equal, no? Okay, or 16 by 19. What is the value of 16 by 19? 9, guys. One moment. We have assumed that the distance is 144 kilometers. Okay, then speed of 1 is equal to distance by speed is equal to distance by time. So this is your speed, 16 kmph, and 9 kmph is your um, speed. With this speed, they will reach Patna and Howrah respectively, right? Okay. Then what is the ratio of their speeds? The ratio of their speed is S1 by S2, or do we have any flaw in this 144? Okay, 144. Okay, let's just assume not 144. Instead of that, let's just assume that this is your Howrah, this is your Patna. Distance is D, and it travels at the speed of and in 9 hours, and it travels in 16 hours. Okay, so from Howrah to Patna, what are the scenarios? Speed is equal to distance by time. Okay, or in other words, distance is equal to speed into time. Okay, so distance is D itself. Speed we don't know, let's call it S1. Okay, time is how much? 9. Okay, so D is equal to 9 S1, right? Now from Patna to Howrah, what is the situation? Speed is equal to distance by time. This is the universal formula. So that means distance is equal to speed into time. Speed we do not know. Let's call it S2, and time is taken is 16 hours. That means 16 S2. Okay, right. Now these D both are same. So that means 9 of S1 is equal to 16 of S2. Okay, so that means S1 divided by S2 is equal to 16 by 9, right?
Yes.
Then why they have given root under T2 by T1? I'm not getting. Why they have given root under T2 by T1?
Sir, I think the meaning of the question is different.
Yeah.
After they met, the train reaches the destination after 9 hours, sir. So there's a time
Oh,
before they meet each other. That's why they making the route. Otherwise, it would be like this.
oh, okay. Now I got it. Okay. So the meaning of over here is A and B towards each other, and after crossing each other, they take okay. That's the problem. Okay. So they, let's say they crossed each other, it takes only 9 hours. That means this was a faster. Okay. After crossing, they were like they reached over here T1. After crossing, this one take T2, and this one took T2. Okay. The one going from Howrah to Patna, after crossing, let's call it AC, it took T1 time or T2 time. This one is T1, right? Yeah. This one is T1 time, and from Patna to Howrah, after crossing, it will take how much? This is H and this is your P. This is took your H2 time. Right? Right, guys. So in
Yes, sir.
that case, this time is about for this train traveling for this time period, for this actual distance, and this time T2 is for this train traveling after meeting this. Okay, and that is why for that they have put in this root under what they have put in. Okay,
Times.
yeah, root under time T2 by T1. What is T2 over here? T2 is 16 by 9, that means 4 by 3. Okay, let's just try now understand it. Let's take some scenario, a little bit of more scenario. Okay, let us say from A to B, right? the distance is let's say 144 kilometers only. A takes 9 hours and B takes 16 hours. So obviously the speed of A is 16 kmph and speed of B is 9 kmph, right? At what point will they be meeting? At what point will they be meeting, guys? Okay, both of them are traveling in the same direction. Okay, they need to cover 144 kilometers. Okay, both of them are traveling in the same direction. That is why what we'll do, we'll just add these two speed. Okay, over here it's distance and over here it's speed. That means will be time at crossing, at what particular time they will be crossing each other. Okay, so that is your 144 divided by 25. At this hour they will be crossing each other, right? And at this hour A might have traveled how much of distance? A must have traveled 144 divided by 25 into 16. It's getting just so cumbersome. Okay,
Sir,
yes.
why you write 144 by 16 plus 9?
Why
The
I have
distance is
written?
144. Fine.
Yeah,
Uh,
I'm trying to find out their meeting point. I'm trying to find out their meeting point, right? One is traveling from this to this, another one is traveling from this to this direction. So they will meet somewhere. And if they are meeting, their relative speed will be added, right?
sir.
Right now. So A will cover this much of distance at the time of meeting. Okay. At the time of meeting, let's call
But,
it A.
sir,
Yes.
why did you take 9 hours and take 16 kilometers, sir? Because it only traveled after crossing each other, they took 6 and 16 and 9 hours, right? So it is not the total time taken to cover the 144, right? It's a partial time, right? Then how can you take the 16 kilometer of speed?
You are right. We should take some different values, right?
Yes, sir.
But the problem is that the only information that they have given over here is after time. Okay. So let's try to build it in a little bit of different form. Okay.
Here, if they meet each other, the time taken for the both of the train would be equal, sir.
One
So
moment.
we can assume that as a t.
One moment.
Can
Let's say this is Havra and this is Patna. Okay. From here to here, it travels at 9 hours. Okay. Let us just try to assume. Let's just try to assume the speed. Let's just try to assume the speed. Okay. So in that case, this train, the speed is we don't really know at what particular speed they are traveling. Okay. It just pretty difficult to build from, you know, from bottom to top. Okay, okay. Let's just try to work around it. Do you have any idea over there?
Sir, same as you do, we
Yeah,
can use
yeah.
take that 144 as a kilometer, sir. No issue. But we have to take after crossing each other, they took 9 hours and 16 hours, right? We
Yes,
have to add t to both of the times, so because they
yes,
would take same time to cross each other, right?
yes, yes, absolutely,
So we can
absolutely.
add up that.
So let's assume that as T.
Sir.
Okay. So over here is T and over here is 16 hours. Okay. So from Havra, it's like the time is how much? Time is 9 plus T, and from Patna, it's the timing is 16 plus T. Okay. And distance, we have assumed 144. Right? Distance we have assumed 144. Okay. Yeah, distance will remain the constant, right? Okay. So now we'll come across the speed. Okay. So speed Havra is equal to distance by time, and speed of the train leaving from Patna is distance by time. Now what?
Sir, to get a ratio for this, we need
Yeah,
definitely a speed of
we
trains.
definitely need the speed of the train, right?
Yes, sir.
We'll
Otherwise,
have
we
to,
won't be able to get the
yeah,
value of t.
yeah. If you look closely, if you look guys closely, okay, if by any chance, if we replace this value by t is equal to, let's replace some value, both are t only, okay. These two, yeah, we have like, three different variables, uh, Havra, Patna and T, and we have only got two equations. So it's not possible for us to solve this way. Okay. But 16. Can you think of some number as T which essentially divides 144, both 144, the Havra and the Patna one, both of them? Can we think of that such numbers as such? Okay. 144. Okay. It's 1, 2, 3, 4, 5, 6, but it won't work out. Okay, let's work it out this way. 24, 12. We are kind of trying to derive the formula over here, guys. Okay,
I
just a sec.
think, sir, by putting 12, we can get the answer, sir.
Can we put 12? T is
In
equal
t, sir.
to 12. Okay, 12 plus 9. T1, T2, S1, S2. Okay, so T1, T2 times. Okay. If we put 12 over here, 12 plus 9 is how much? 21. Okay. And 144 divided by 21. It doesn't work out, buddy. 748. It doesn't work out. Okay. So basically over here, speed of, let's say, Howrah divided by speed of Patna is equal to 144 by 9 plus t into 16 plus t divided by 144. Okay. So Havra and Patna is equal to 16 plus t and 9 plus t. Okay. This is the speed. Now what? Just root under T2 by T1, they have said. It's a very good question, guys. I remember this question being taught by my CAT maths mentor. Okay. We had to think like hell, but if we think a bit more, we need to have some speed over here. Can we assume some speed? Okay, guys, look, let's work it out once more. This is the last time we'll be working it out. Otherwise, we'll be working it out again, but later. Okay, thinking about it later on. So let's try now assume 144 as the speed. Okay, and we do not know. Okay, let's just chuck this 9 hour and 16 hours. Okay, let's just chuck this one. Okay, let's just assume that the train traveling from Havra, the speed of that is 16 kmph. Let's just assume that. Okay, and let's just assume that the train traveling from Patna at 9 kmph, right? Or otherwise 9 plus 144, 72, 36. Okay, 36, 16, 18, 18, 2. Yes, let's assume 16 and 18. Okay, what are we assuming this is speed as your, but sometimes this calculation is bound to get cumbersome for sure. Okay, so over here the speed will be 144 by 16, which will be 9, and over here your speed will be 144 by 18. How much is that? 8, right? And now the meeting point will be at what? 144 by 16 plus 18. That means 144 divided by 32, right? 72, 36. It's just very hard for us to find this 36. If we take 20, yeah, So let's just take the meeting point is this one. So 72, 16, it's 4.5 hours, right? 4.5 hours. And then 4.5 hours means what? This is traveling at the speed of 8 kmph. Okay. So it must have traveled from here to here in 4.8 hours, 32 plus 4. That means 36 kilometers. 36 kilometers it must have traveled, right? And in 4.5 hours, 9 into 4.5, 36 plus 5, 36 plus 4.5. We assumed 144 kilometer is your distance. Okay. 16 kilometers, no, 16 hours. Okay, 16 hours. Over here it is 18 hours. Okay, to complete the 18 hours, 16 hours to complete the journey, right? So 18 into 8, 144. 16 into 9, 144, right? Okay. Oh yeah, guys, the calculation will get so cumbersome, so cumbersome. Okay. Let's just chuck it for now. Okay, guys, we'll talk about this one again. How about that? Okay,
So,
just chuck it for now. In the interest of time, it's already 10:23. See, it's not easy to build it from from bottom up. Okay, bottom up. In the most of the cases we are able to build it. Okay, many a times these formulas does help you. Okay, like this. Okay, it will help us from all these cumbersome thing that we are facing right now. Okay, and it's not an easy task to find out, let's say, some distance is also not given. After meeting the train A takes t times, okay, t1 times, and after meeting at this particular time the train B takes t2 times. Okay, and then their average speed s1 and s2 is t2 by t1. Okay, this is what you need to keep in mind. And I was just curious enough to understand how and why we reached this one. Okay, the mathematicians out there, they work with big numbers, they work with calculators. Okay, and it's easy for them to work out. Okay, we also tried using it, but we could not find some good numbers, right? So I'll think through it and I'll let you know this one again. How about that? Okay, cool. Shall we move, guys, for now? Yes or no? Or
yes, sir.
shall we do it this one all over again?
No, sir. We can move next one. We can do later.
Okay, yeah. So these are the problems of the boats. You all know it. Boats problems based on the boats and stream. Boats and stream is an application of speed, time, and distance. Some of the important terms are still water. Okay, at still water, the speed of the water is 0. Okay, the stream water, the moving water is called the stream water, and it will have some certain stream. Downstream. Okay, downstream means what? Downstream means what? You know, downstream means the river is flowing down, okay, in the direction of the flow. Okay, the direction of the flow, right? Upstream is against the direction of the flow, right? So some of the rules, the problems that they have mentioned over here related to boat and stream, it is pretty much self-explanatory. Downstream, what happens that you know the direction of the stream is this, and boat is this. Let's say the boat is this. Obviously, the boat doesn't look like this, and the direction is also this. Okay, it's B and the stream S. Okay, so the effective speed becomes B plus S, and in this case wherein the speed of the boat is B and the speed of the stream is S, and these two are in two different directions. So in that case, what happens? The speed of the boat gets reduced by the speed of the stream, because boat is trying to move to the left hand side and the stream is trying to pull it to the right hand side, right? So to a sailor goes 8 kilometers downstream in 40 minutes and returns back in 1 hour. Okay, then the speed of the sailor in still water is how much? Okay, so 8 kilometers downstream. Okay, so downstream is what might have happened. Downstream, the case was distance is equal to speed into time. Okay, distance. Okay, distance is equal to speed into time. So distance is 8 kilometers. Okay, divided by time. Time is your 40 by 60 is equal to your effective speed. Okay, downstream, that means x plus y, right? S is equal to x plus y. So now solving this one over here, 8 into 60 by 40, 12. That means x plus y is equal to 12. That's 1. And it came in 1 hour. Okay, 8 is equal to x minus y is equal to 8. Now solving all these two got cancelled. Okay, x 2x is equal to 20. That means x is equal to 10, right? If x is equal to 10, then y is equal to 2, right? And what is y? Y is your speed of the current, right guys? So B is your correct answer over here, right? So we shall move to the next question, guys. Next, the concept, right? So this concept says that the speed of the boat in downstream is u kilometer per hour. Speed of the boat downstream, speed of the boat in downstream is u kilometer per hour. Okay, and speed of the boat, the effective speed of the boat in upstream is what? V kilometer per hour. Okay, so for that they have given the formula over here. Number one, speed of the boat in still hour, in still water, sorry, in still water is given by half of u plus v. Okay, so in the question over here, the speed of the boat upstream and the downstream, upstream is 7 and the downstream is 13. So 7 plus 13, which is equal to your 10 kmph. Okay, then this is the speed of the boat in still water. Okay, let's write it like this. Okay, the second one, it says speed of the stream, the current. Okay, the speed of the current is how much? Half of u minus v. Okay, half of u minus v, that means half of 13 minus 7, that means half of 6. So that means your 3 kmph is the speed of the stream, right? Is it clear, guys? Is it clear, guys?
Yes.
Look, guys, let's just try to assume, okay, speed of the boat, let us say it is 10 kmph. It is separately from the question. Okay, we are not worried about the question. Okay, then speed of the stream, we are assuming it 2 kmph. Okay, so upstream, this is the speed of the boat in still water. Okay, in still water. Okay, in still water. Then upstream speed will be how much? 10 minus 2, 8 kmph. Downstream speed will be how much? 10 plus 2, that means 12 kmph. Okay, effective speed, these two, adding these two, 8 plus 2 by 2, what do we get? 10. Is it this value, guys? Is it this value? Is it this value? And now stream, the speed of the stream, 4 by 2. Is it this value? Speed of the stream. This is what they have said in this two formulas. Is it clear, guys? Is it clear? These were easy for us to assume some numbers, and that's why we were able to do it. And we'll find some good number for the other one as well. Okay. We'll move to the next concept now. Yep. The last one for the day. I mean, I don't know whether I'll be taking your class at 11. Maybe, shall we move it to the morning, guys? Shall we move it to the morning? Your 11 p.m. class for today? Okay. So
When we
Yeah, in the morning 6 a.m. maybe.
Okay, sir.
So in the race is a contest of speed in running, diving, riding, sailing, rowing over a specified distance is called a race. Suppose A and B are two contestants in a race. Okay, if A beats B by X meter and the length of the track is D meter, then the distance traveled by B when A finishes the race is D minus X, and speed of A by speed of B is equal to D by D minus X. Okay. What it is telling is that the distance traveled by B when A finishes the race. Since A has bet B by X meter, that means B must have traveled X minus D minus X meters. That's what they have given over here. The total length of the track is D, and it has been B has been bet by A by X meters. So this is the speed, and speed of A by speed of B is equal to D divided by D minus X. Okay. D divided by D minus X. Okay. Let's just assume some numbers. Okay. Let's just assume some numbers. Yeah, note 1 over here they have given. A gives B a start of X meters, means A starts at starting point and B start X meter ahead of point B. A gives B start of T seconds, means A start T seconds after B starts from point B. Okay. Let's just assume that it's a 100-meter race. Right, guys? Right.
Yes, sir.
Speed of A is 5 meter per second. Let's say that. Speed of B is 10 meter per second. It's completely different from what the question they have given over here. We're just trying to prove this formula using some numbers. Right? So obviously, T of A, time of A will be 20 seconds and time of B will be 10 seconds. Right, guys? So far, so good.
Yes, sir.
So far, so good. In 10 seconds, B must have completed the race. In 10 seconds, this is the race, let's say, okay, 100 meters. After 10 seconds, B is here, B completed the race, but A is somewhere here only.
Yes, sir.
Okay, after 10 seconds, A has traveled only 50 meters. A traveled 50 meters only,
Yes, sir.
right? A travels only 50 meters. That means A was beaten by 50 meters, right? Now, D minus X, this is pretty much explainable, self-explanatory, right? Then speed of A by speed of B, right? Speed of A by speed of B, that means 5 by 10 is equal to D. D means how much of distance by which it was being beaten. That means 50, and D minus X. D minus X is how much? D minus X is the beaten by, sorry. Okay. One moment. Yeah. Over here, the person who wins, okay, that one has to be written first. Okay. Speed of B by speed of B, because B has won it. Okay. So D by D minus X. So that means speed of B by A. We don't know, we want to reach this number. Okay. Speed of B by A is how much? 10 by 5, which means we should be able to reach 2. Okay. D, it was defeated by,
Sir, D is the distance of track.
oh yeah, D is the distance of track. Sorry. Thank you so much. Yeah. And D minus X, D is 100 minus 50. That means 100 divided by 50, which means we get 2. Right. Let's read this question. In a 200-meter race, A can beat B by 50 meter and B can beat B by C by 8 meters. In the same race, A can beat by C by how much of distance? By how much of distance, guys? In a 200-meter race, A can beat B by 50 meters and B can beat C by 8 meters. In the same race, A can beat C by how many meters? Let's just try to understand it this way. This is your racetrack, 200 meters, right? This is your racetrack, 200 meters. 1 second, guys, just give me one moment. Yes, guys, so it's a 200-meter racetrack, right? If at this point when A reaches over here, okay, yeah, 1 second. If A reaches over here, then B is somewhere here. B is somewhere here at 150 meters, right now. B is somewhere here at 150 meters, right? B is somewhere here at 150 meters, right? No. And we don't know where exactly C is. We don't know where exactly C is. Okay. So, in 200 meters, B takes a gap of 8 meters. Okay. B is ahead of C by 8 meters, right? If it was a 1 meter race, it must have been like this. But when A reaches here, B has only completed 150 meters, right, guys? That means when B is at this point, what must have been the gap? Because this 8-meter gap, it is saying that when B is at this point, C is at this point at 8-meter gap. Are you guys getting it? Are you guys
Yes, sir.
getting it? Yes or no? That means 3, 4, 2, 12. Okay, right? Right now. So that means what? That means what? Okay. At, no, 1 second. 3 by 4, 3 by 4. Yeah, it's just 6. Sorry. It's not 12. Yes. Okay. So when B is here at 150th meter, C is here at 144 meter. That's it. Okay. So by how much distance C A has beaten C? By how much distance? 200 minus 144. How much is that? 66, guys. Okay. Cool. Is it clear, guys?
Sir,
Boys?
can you tell me once more, sir?
Yeah. Cool. For sure. Thank you so much for asking. When A is at 200 meters, B is at 150 meters.
Yes, sir.
Clear. But we don't know where exactly C is. We only know when B is at 200 meters, C will be at 192 meters. Then only the gap will be at 8 meters, no?
Sir.
Right. This gap that they have given over here, that is for 200 meters. But actually, to find in relation to A, we'll have to ensure that this gap is only 50 meters, right? The B will have to be placed at second position. Then we'll have to find the gap. That means we'll have to truncate this race from 200 meters. The gap was 8. For 100 meters, the gap must have been 208 by 200. And for this 100 meters, the gap must have been 8 by 200 into 150, which is 6,
Yes, sir.
right? So that means when this was at 150th meter, C was at 144 meters, right? That means the gap between these two was how much? How much, guys? 56,
Yes, sir.
right? No, 56 meters. Did you get it?
Yes.
Did you get it? Think over it. Okay. It's such an interesting one. Think over it. Okay. Thank you so much for joining. We'll meet tomorrow.